Hi everyone, today we'll be going over designing a wall footing example in ClearCalcs. So we'll go ahead and open our wall footing. The example we'll be going over today is from J. White's Reinforced Concrete Mechanics and Design, and it's example 15.1, Design of a Wall Footing. So the example says, a 12-inch concrete wall carries a service load of 10 kips per foot and a service live load of 12.5 kips per foot. So from that information, we can go over here and say that it's a 12-inch wall width. And if we head down to the loads, we can put in 10 for dead load and 12.5 for live load. And then the next portion of the example says, from the geotechnical report, the allowable soil pressure is found to be 5,000 psf for shallow foundation. So we can edit that portion of, so we can edit that here. The allowable soil pressure can be 5,000 psf. Then it says, design the wall footing to be based 5 foot below the final ground surface using an F prime C of 3,000 normal weight concrete and a rebar yield strength of 60 ksi. So we can set the depth of footing below ground here. So instead of 2 feet, the question asks for 5 feet. So this footing is 5 feet below ground, and the concrete strength is to be set at 3,000 psi. 3,000, while the reinforcement yield strength is 60 ksi. So that's already noted here. Then we know that the question tells us that the soil density is 120 pounds per foot cubed. And most strip footings on soil have 1 mat of reinforcement. So here we can go to unit weight of soil. It is 120 pounds per cube foot. And this is all the input parameters of our footing. So now let's go ahead and design it. So we can see that we're failing a little bit in bearing. And in order to reduce that, we can actually just increase our footing width to 6 feet. And then it looks like we're failing in shear. So we can reduce our shear failure by increasing the footing thickness, so to 14 inches. And it looks like we're just passing. And so based on this design, we know that for this particular configuration, we want a 6 by 14 footing with number 5 at 10 inches of transverse reinforcement, and number 5 and 6 number 5s of longitudinal reinforcement. And we don't need top reinforcement, and that will be sufficient for the loads applied in this question. And that's all for this example.